Hey everyone, welcome back to the channel. In today's video, we're going to explore the Fluent Builder Pattern in C#, what it is, when to use it, and why it's such a powerful pattern for building complex objects step by step. The Builder Pattern is a creational design pattern that lets you construct complex objects one step at a time. Instead of packing everything into a constructor, which can quickly get messy, the Builder gives you a clean, controlled way to build up the object, piece by piece. It also separates how the object is constructed from what the object actually is, which follows the single responsibility principle. When you have a class that takes 5 or more parameters, things start to break down. You either overload constructors, pass values in the wrong order, or include things you don't even need. It becomes harder to understand, harder to maintain, and easy to misuse. The Fluent Builder Pattern is a modern take on the Builder Pattern, using method chaining for better readability and flexibility. You'll want to use this when your object has a mix of required and optional values, and you don't want to pass everything into a constructor. It's great when you want your API to be intuitive and easy to use. And it works really well with immutable objects, where you only set the values once and never change them again. This style is common in .NET. You've probably seen it with things like DB Context Options Builder, Web Host Builder, or even String Builder. Let's quickly go over the benefits. First, your code becomes super readable. It flows top to bottom and makes it easy to see what's being set. Second, it handles optional values naturally. No need for multiple constructor overloads or parameter juggling. Third, it helps you keep the final object immutable, which means safer code. And finally, it matches how modern .NET APIs are designed, so it feels familiar and consistent. Alright, now that we've covered the theory and benefits, let's move into the code. Here's what we're going to build in this example. We'll create a simple report generator in C#. This report will have a title, optional headers, optional data rows, an optional footer, and an export format, like PDF or Excel. We'll use the Fluent Builder Pattern to construct this report step by step, making the code clean, readable, and easy to extend. So, let's start by defining the object we actually want to build, the report class. Public sealed class report. I'm making it sealed here because we don't need other classes to inherit from it. This helps keep it simple and prevents unintended extension. First, we have the title property. It's a string, and it will hold the title of our report. Next, we'll define the headers property. This is a list of strings, each one representing a column header in our report. Then comes the rows property. This is a list of lists of strings. Each inner list represents a row of data in our report. Now we'll add the footer property. This is a string that can contain any summary or additional note at the bottom of the report. And finally, the format property. This uses our report format is to specify whether the report is PDF, Excel, or any other supported type. But using plain strings for something that only has a few fixed values isn't the best approach. It's easy to make typos and harder to maintain. So instead, we'll replace this with an enum. That way, we have a predefined list of valid formats and get the benefits of type safety in our code. Let's define the report format enum. This will hold the different formats our report can be exported in. For now, I'll add 2 options, PDF for PDF format, and Excel for Excel spreadsheets. Now that we have the report format enum, let's go back to our report class and update the format property. This means the property can now only take one of the predefined enum values, like report format, PDF or report format, Excel, which gives us type safety and avoids accidental typos in format names. Now let's create our report builder class. I'm making this class sealed as well, because we don't need other classes to inherit from it. Inside, we'll define private fields to hold the data while we're building the report. First, I'll add the title field. Here _title will temporarily store the report title while we're building it, and we assign it to string, empty as the default value. Next, I'll add the headers field. Here _headers will store the list of column headers, and we assign it to an empty list as the default value. Then, I'll add the rows field. Here _rows will hold all the rows of data for the report, and we assign it to an empty list as the default value. Now, I'll add the footer field. Here _footer will store the footer text of the report. Finally, I'll add the format field. Here _format will store the format type of the report, and we assign it to report format, PDF as the default value. Next, I'll add a static factory method called empty. This method returns a new report builder instance with all the default values we've set above. The empty method gives us a clear, consistent way to start building a report without having to call the constructor directly. Next, I'll add a private constructor. This ensures that no one can directly create a new instance of Report Builder using the new keyword, forcing them to use our static factory method instead. Now, I'll add our Fluent methods for building the report. First, I'll add the withTitle method. This method sets _title to the given title value. It then returns the same Report Builder instance, and that's what makes this a Fluent method. It means we can chain it with other methods, like .addHeaders or .withFooter, all in one smooth line of code. Next, I am going to explore addHeaders method. This method takes one or more column header names as parameters, for example, things like product, region, or revenue. Inside, it adds those header names to our _headers list, which is where we keep all the column headings for the report. And just like with title, it returns the same builder instance, which means we can immediately chain the next step in building our report, maybe adding rows, setting a footer, or changing the export format, all in a clean, Fluent way. Then, I am going to add row method. This method takes one or more cell values, creates a row. Then, I'll add the given rows to _rows. This method also returns the same Report Builder instance. Next, I'll add another method called withFooter. This one takes a single parameter for the footer text. This method sets the footer field to the given text. If nothing is provided, it will automatically create a default message, something like generated on followed by the current date. So we never end up with a blank footer. And just like the other methods, it returns the same Report Builder instance. Finally, I'm going to add another method called exportAs, which takes a report format enum as its only parameter, and then returns the Report Builder instance. This method sets format field to the chosen format, like report format PDF or Excel. At the end, I'll add the build method. This method takes all the values stored in title, headers, rows, footer, and format fields and uses them to create a new report object. This is the point where our builder hands back a fully constructed report. Now that we've created the build method, I'm going to update how we set the title. If no title is provided, our report will automatically get a default title of untitled report. Alright, now I'll move the report class into its own separate file. And I'll also move the report format enum into the same file as the report class, since it's closely related to that class. Finally, I'll move the Report Builder class into its own separate file. Next, I'm going to change the properties in the report class. Right now, they're using a standard set accessor. I'll replace the set with an init. The reason is that init setters allow these properties to be set only during object initialization. After that, they're effectively read-only. This helps us achieve immutability, meaning the report's data can't be modified after it's built, which is exactly what we want for a finished report. Now I'm going to add a method called generate to the report class. His method is just for demonstration purposes. It will print out the report details to the console. Inside, we start by writing out a message showing the format, like generating PDF report. Then we print the title, followed by the headers, and then each row of data in the report. Finally, we display the footer. This isn't a real export to PDF or Excel, but it's a quick way to see what our builder has created without adding extra complexity right now. Now, let's see our Report Builder in action. I'll start with Report Builder empty to get a fresh builder instance with all the default values. Then, I'll chain .withTitle, Sales Report Q2, to set the report title. Next, I'll specify the report's column headers by calling addHeaders. Here, we have 3 columns, product, region, and revenue, which define the structure of our report table. After that, I'll add 2 rows of data, one for laptop sales in the US and one for monitor sales in the US, each with their respective revenue. I'll then call the withFooter method and pass in a footer text. In this case, I pass generated on current date and time, so our report clearly shows when it was generated. Then, I'll set the output format to PDF by passing report format, PDF into the exportAs method. Finally, I'll call build method to create the finished report object and store it in a variable so we can use it later in the code. Now that we have our report object, I'll call generate method. This will run the demo output method we created earlier, printing the report details to the console so we can confirm everything was built correctly. Alright, let's run the application, and I'll walk you through the output so you can see exactly what our builder has created. I'll also add a few breakpoints in the code. This way, we can step through the builder process and see how each method updates the internal state before the final report is built. We've stopped at our first breakpoint inside the empty method. Next, the execution stops at the withTitle method. Here, we take the title passed in this case, Sales Report Q2. Now we've hit the addHeaders method. Here we're passing 3 column names, product, region, and revenue. Next, we've stopped at the addRow method. Here, we're adding a laptop, US, and $40,000. We're back at the addDraw method again, but this time we're adding a different row of data, monitor, US, and $20,000. Now we're at the withFooter method. We passed in a footer text and the current UTC date and time. Now we've reached the export as method. Finally, we've hit the build method. This is where the magic happens. All the values we've been setting in the builder are now used to create a new report object. Now the execution moves to generate method. This method outputs the report details to the console, the title, headers, all the rows, and the footer, so we can verify that everything was built exactly as intended. With everything ready, let's continue running the application and look at the console output. Here, you can see the report title at the top, followed by the headers, each row of data, and finally the footers showing when the report was generated. Each section you see here directly maps to a method we called on the builder, which makes it really easy to trace how the object was assembled. This is one of the biggest advantages of the Fluent Builder Pattern. The code tells a story, step by step, from an empty object to a fully formed result. And that's the full journey of building a report using the Fluent Builder Pattern, starting from an empty builder, setting each part step by step, and finally generating a complete, ready-to-use report. This approach keeps our code clean, readable, and easy to maintain, especially when creating complex objects with many optional parts. If you found this helpful, make sure to like the video and subscribe for more practical C# and .NET tutorials. Thanks for watching and happy coding.